Hello again. Today we want to look at work, energy, and power. A man pushing a wall and gets exhausted does no work, since the force applied does not cause a displacement of the wall. Work is said to be done when the force acts on an object to cause a displacement. Note, the displacement may not be in the direction of the force. The work done on an object by a force may be positive, negative, or zero, and the formula for work done is force times displacement. Work done is a scalar quantity and it has a unit in joules or Newton meter. Work done, as said earlier, may be positive, negative, or zero. It is positive when the force and displacement are in the same direction. It is negative when the force and displacement are in the opposite direction, e.g., a car skidding to a stop on a roadway. And work done could be zero when the force and displacement are perpendicular to each other, as in the case of a man pushing the wall. Now let's take some examples. The first question. A 2 kg object is pulled upwards at constant speed by a force P. If the vertical displacement is 5 meters, find the amount of work done. We are asked to take acceleration due to gravity as 10 meters per second squared. Here is the solution. This is the object. The force that pulls this object is P. And of course, the weight of the object would be 2 g-newtons, where g is the acceleration due to gravity. Now, the vertical displacement is 5 meters. We can see that both force and displacement go in the same direction. So we expect our work done here to be positive. Now, the forces are balanced out at constant speed, which means that these two forces cancel out since there is no net force in the vertical direction. We're told that the object moves with a constant speed, and that is why our P will equal 2g, and that will give us 20 newtons. Since work done is force times displacement, our force is 20 newtons and the displacement is 5 meters, and that gives us 100 joules. Second question. How much work is done by a 10 Newton frictional force, which slows a moving block to a stop after a displacement of 5 meters to the right? Now, since this block is displayed to the right by 5 meters, then the frictional force must act in opposite direction to this motion. Now, since both frictional force and the displacement direction of motion are in the opposite direction, then we expect the work done on this block to be negative. That is why we have it to be 50 minus 50 joules. Now to the third question. A block is pulled horizontally through 4 meters at a steady speed by a force of 50 newtons, inclined at an angle of 60 degrees to the line of motion. Find the work done. Here is the diagram involved in the question. Now, this block is being moved or dragged forward by this horizontal component of this force of 50 newtons, and was being displaced by 4 meters. And the displacement, you can see the displacement, both displacement and force are in the same direction. So the work done here is positive. Now, to calculate the work done is to multiply this component of the force of 50 newtons by the displacement, and that gives us 100 joules. The fourth question. Calculate the work done by a 2 newtons force directed at a 30 degrees angle to the vertical to move a 0.5 kg box a horizontal distance of 4 meters across a rough floor at a constant speed of 0.5 meter per second. the solution. Here is the diagram. Now, the force that moves this block forward along this rough floor is this horizontal component of the force, 2 newtons, which is 2 cos 60. Since the two angles here add up to 90 degrees, so if this is 30, of course, this should be 60, and that makes this component 2 cos 60 newtons. Now, this block is being displaced a distance of 4 meters forward. Since the horizontal component and the displacement act in the same direction, we expect our work done to be positive. Now, to calculate the work done is to multiply these two things together, and that gives us 4 joules. Now to the last question on work. A mass of 20 kg is pulled across a rough horizontal floor. Coefficient of friction is 0.4 through 2 meters at a steady speed by a horizontal force. Find the work done. The horizontal force is this forward force, and that equals the friction that acts in the opposite direction since the body is moved at a steady speed. So that means all the forces acting on this block or box must be equal. That is, the vertical forces are equal as well as the horizontal. So this horizontal force, which is F, must be equal to the product of mu and R. And we should remember from our previous lessons that this frictional force must operate at its maximum possible value. And that makes our F, which is the horizontal force, to be 0.4 times 20, which was given, which happens to be the mass of the block times the acceleration due to gravity, and that gives us 78.4 newtons. Now, to find the work done is to multiply this force uh, by the forward displacement, and that will give us 156.8 joules.